Hi everyone, in this video we will talk about HCSR04 ultrasonic sensor, how to connect it with Arduino board, as well as we will show you how to install the HCSR04 software library within Arduino IDE. Once the library is installed, we will open one example program from the installed library. We will install the same example into Arduino board and test how it works. In next video, we will expand the simple program came along with the library using LEDs and buzzer. This is the Arduino IDE version 1.8.9. The interface might have not been changed if you are using the latest version. You go to the sketch menu, go to include library option and click on the manage libraries option. Give it a couple of seconds. The dialog box will open, and once the dialog box is open, it will identify all the installed libraries in your computer. Once the search is complete, you can click on this search bar. You type HCSR04. Now it popped up so many libraries, but we will try to find out what is the best library, and we'll go to HCSR04, which gives us the distance in microseconds, millimeters, centimeters and inches. By default it has so many versions from version 1 to version 1.1.2. We will install the latest version. You click on this install button. The installation will take a couple of seconds. Once the installation is done, here safely you can click on close. Now a little bit about the licensing of the library whatever we have installed. This is made with MIT license and by the grace of Ultrasonic, and thanks to him for providing the software. And as you see, we can actually use his software without much of the restrictions for the exploratory purpose as well. Now we will open the example program from the HCSR04 library. Go to file menu, examples, and navigate to the HCSR04 and the simple program. This program comes with a little bit of code, and the HCSR04.h is a header file required if we want to use the HCSR04 library. And as you see, trigger pin is 21 and echo pin is 12, but as you see in the Arduino we do not have this many number of pins, so let's change this to pin 7, digital pin 7, and this will be echo pin will be digital pin 6, and save the program. Once the program is saved, you can see the loop which runs continuously within the Arduino has a delay of 250 milliseconds. So that indicates this entire loop will execute 4 times in every second, and this distance is calculated 4 times in every second because of the 250 milliseconds delay. If you want to calculate this distance at higher frequencies, probably 10 times per second, you can reduce the delay. Instead of 250 milliseconds, you can keep 100 milliseconds. And as well as the serial.begin indicates that we want to send this data on the serial monitor with 9600 is the baud rate. And as you see, this distance is a double pointer, and the first element in this array will provide the distance with centimeters as units. As you see, the object is closer to the sensor, so the distance, whatever it is representing in the monitor, is less. Now I will slowly move the object farther away from the sensor, so as you see, the distance also getting changed proportionately. Now I am actually moving again closer to the sensor, so the distance is getting reduced. Now I am moving away and the distance is getting increased. The pin connection between Arduino as well as the HCSR04 is like this. The VCC pin of sensor is connected to the 5 volts pin of Arduino, and the ground pin of the sensor is connected to the ground pin of the Arduino. Echo pin of the sensor is connected to the digital pin 6 of Arduino. The trigger pin of the sensor is connected to the digital pin 7 of the Arduino. As we discussed, HCSR04 has total 4 pins. One is VCC, the second one is trigger, the third one is echo, and the fourth one is ground. VCC supplies the voltage from Arduino or maybe from any other external source to all the chips or all the circuit within the HCSR04, and as well as ground provides the return current. Now coming to the trigger, this will receive the signal from Arduino and echo will transmit the signal to the Arduino. What exactly this is, when we write any program, the Arduino library will send the trigger on this pin, the second pin, and the received signal, that is called echo, is received on this pin.